Hi, and welcome to the Math Essentials video podcast series. This is part 2 of section 1.2, which deals with the equation of a line. In this podcast, we're dealing with the equation for a partial linear relation. So remember, the equation that we can use to calculate a direct linear equation is y equals mx. And so what we're going to do is we're actually going to add another variable to this, and that's for a partial. So remember, a partial linear equation does not go through zero, and so we need to account for the fact that our line is not going to go through the origin, but it goes through some other point in the origin. And so that is where the b comes in. So the y is going to be the same, right? The y is going to be your dependent variable. The m is going to be equal to your slope. The x is your independent variable. Go IV. And the b is known as the y-intercept. It's the place on the line where the line touches the y-axis. Okay, so as an example, we can look at this right here. This is the example out of the book. So if we look at a furnace repairman, the furnace repairman, just to actually visit, is going to charge a flat fee of $95. So you can see that at time zero, or just to go to the house, there's $95 charge. Every point after that is a $75 an hour rate. Okay, so for every hour he charges $75. So what we can do with this information is, if we looked at the graph for this particular value here, we would see that it does not start at the origin. It starts at 95, right? So if that was 100, we would start somewhere about 95, and that would be part of our line. Now, to calculate the slope of that line, again, we would need to find some ordered pairs. So we would need to find the slope. So in order to do that, you can take this value and this value, and your slope will give you these values will give you the slope of the line. So we're going to do an example in which we use the formula y equals mx plus b in order to calculate the slope of this line. And so we're using the example out of the textbook, and basically what it says is that, at this time, so at about 2:30, she measures the depth of the water to be 32 centimeters. 45 minutes later, she measures the depth again, and it's 11 centimeters. So the pool be emptied before 4 o'clock. So we're assuming that in our case, in our example, the pool is emptying at a steady rate. And so if that's the case, then I have two sets. I have time 0, which the pool starts at 32. And then I have time 45, in which the pool is at 11, right? So that's the second time. So I have two ordered pairs that I would put on this graph. So if I was going to do a graph, if this was my 50, and the graph may be at 0 times 0, right? Time is my independent. My dependent would be the centimeters depth of water. And so 32 would be somewhere here, and my line would go up in some sort of a linear fashion. So to calculate this line in particular, what I need to do is, first of all, calculate the slope. So slope, I use the same formula, so rise over run, or y2 minus y1 over x2 minus x1. So when I plug in my values for slope, I get 11 minus 32, right? y2, y1, and I divide that by x2, or 45 minus 0. And so my slope is actually going to be, because remember, water's decreasing, so I will have a negative slope, negative 21 over 45, and calculating that out as a decimal, I get negative 0.467. Okay, so now when I apply that into my line, so I know that my line y is equal to mx plus b. So to solve for b, what I do is I take 2 points. I take 2 points on my line, or one set of ordered pairs. So I'm going to take the easy one. I'm going to assume it's at 0 and 32 in order to calculate what my y-intercept is for the line. So to do that, I substitute my 32 where my y is, and that's equal to my slope, which I've already calculated at 0.467, my x value, which was 0, and then plus b. And so this value here, negative 467 times 0 is 0. And so my b value in this formula is 32. So when I actually go to write my equation, which will help to actually solve any sort of questions that I may have on this pool, my equation looks like this. Okay, so now when I actually go to answer this question, if I want to look at when the pool is at 0, so when when the water is empty. So I'm looking at the depth, and I'm going to look at when my depth is here, is at 0. So to do that, that is my y value. So now all I have to do is plug in that into my formula. And then all I'm doing is I'm simply going to solve for x. Okay, so remember, to do that, we do opposite operations. Right, so negative 32 is equal to negative 0.467x. And then again, to solve for x, I divide it by that, divide it by that, and my x is going to be equal to 68.5, which we can round to about 70 minutes. So if we wanted to figure out how long it would take to actually empty the pool, we've applied our equation once we know the equation, and we know that it'll take about 70 minutes for the depth of the pool to be equal to 0. And so that's how we can use the partial linear equation of a line, y equals mx plus b. That's how we would solve for b, and that's how we can use it to answer questions.